Okay, number 4 says there's a fourth-degree polynomial. It claims it can be factored in a unique way into a product of two quadratic polynomials with integer coefficient. All right? So let me write this over here, see if I can handle it. X4 minus 27 x squared plus 121 equals, and I said there's two quadratics over here, so I'm just going to buy into their story, and I'll say, oh, probably x squared and x squared, because it said integer coefficients, by the way. That certainly would work. My trouble is I'm not sure what the other guys are. So I'm going to put this over here, ax, quadratic in form, plus b. They might be really, they're integers, they're going to be simple numbers, but I'm not sure what they are at this point. I'm going to say plus cx plus d. I'm going to start to equate coefficients in the problem. Now, equating coefficients could be problematic, but I'm looking at it, and I'm going to multiply it out, right? And how do you do that? Let's do it one step at a time. You get x4, then you're going to get cx cubed, I'm multiplying this across those three terms, plus x squared d. Let's go to the next one. What's next going to be? Plus I'm doing this one now, ax cubed plus acx squared, and then plus adx. I'm going to do this now. What do you get? Bx squared plus bcx plus bd. Okay, there's some things I do know. All right, I'm going to have to go to the whiteboard to finish this off, by the way. So I know that the cubes, if you were to add those together, they'd have to be 0, because there's no cubes. I'll write this down over here. So I know a plus c equals 0. This is a given fact. What else do I know? I know the square term has to be minus 27. So what does that mean? It means d plus ac plus b has to be minus 27. All right, so these are done. Okay, I know this has to sum to 0. I'll write that down. So AD plus BC has to become 0. And BD has to be 121. All right. This one here says that A is the opposite of C. Or you might say C is the opposite of A. Either way, it doesn't matter. So I'm going to put this second equation down now as like D. Let me think about that. Well, you know what? Let me hold off on that. I'm going to do that third equation down. And I'm going to say AD plus B. Now, the C, remember, is minus A, right? And that should be equal to 0. So I guess I could factor the A out. And what would you get there? You would get D minus B is equal to 0. So I got a couple of facts at this point. I mean, I'm not sure what A is at this point, but A is the opposite of C. And now I know that D is equal to B. All right, so B is equal to D. So if that's true, if B is equal to D, that really kind of tells me what B and D are. They're 11. All right, so B and D are 11. So let me get my eraser out. And let me just get a smaller eraser. They have to be equal, right? Let me put that down. Well, actually, I could put down minus 11 too, but let's just say 11 at the time. See if that thing's going to work out for me. So B and D are 11. But I guess you could have said that if they're equal, it could have been minus 11 too. I got to keep going though, don't I? And I got to go over here now. And let's write this down. 11 plus A times C. Well, remember C is minus A. Plus 11 equals minus 27. Well, 11 and 11 is 22. And this is minus A squared is equal to minus 27. And what do you get there? 49 is equal to A squared. So I say A could be plus or minus 7 now. But well, let me just try the other one. If I said minus 11 minus A squared minus 11 is equal to 27. Let's see what happens over there. You get minus 22. I'm sorry, it's minus 27. Plus 27 equals A squared. And that, not possible because A would be not an integer then. So I'm glad I didn't put the minus 11 down. Now the A could be plus or minus 7, which means the C is going to be minus plus 7. And I guess it really doesn't matter what I put down now, does it? Because I see that. It's symmetric. And so I'll get my eraser out. And I think I'm done. Again, A and C are opposite. So whether you put plus 7 here or minus 7, and the opposite would go over here. And we're now done. We got our factorization, by the way. So x squared plus 7x. Oh, you know what? I don't think that was our question. What is the sum of these two polynomials? It wasn't what the polynomial was, the factorization, the sum of those two polynomials. Let's write this down. So x squared plus 7x plus 11 and x squared minus 7x plus 11. If you add those two together, what do you get? You would get 2x squared plus 22. And that's what the answer is for this one. What's the sum of those two polynomials? And we're done. Thank you.